Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A compound is optically inactive if it lacks chirality, i.e., it has no chiral centers, no axial chirality, no planar chirality, or if it is a mesocompound. Analysis of each option. A. The nitrogen atom bears 3 different carbon substituents, ethyl, H3CH2C, methyl, H3C, and phenyl, plus a lone pair. A tertiary amine with 3 different substituents is technically chiral at nitrogen, but nitrogen inverts rapidly, pyramidal inversion, making it optically inactive in practice at room temperature. However, in the context of this question at the level of structural analysis, this compound has a stereogenic nitrogen but it is typically considered chiral. Some questions treat it as chiral. Actually, looking more carefully, this appears to be a quaternary nitrogen or a tertiary amine drawn with wedge dash. If it is a tertiary amine, rapid inversion makes it optically inactive, but as a drawn structure it is often considered chiral. This option would be optically active if nitrogen inversion is slow, but for amines it is fast. B. Phenyl methyl sulfoxide has a chiral sulfur center, 4 different groups, phenyl, methyl, oxygen, and lone pair. This compound is optically active. C. The alene shown is H3C, C6H5, C is equal to C is equal to C, C6H5, CH3. For an alene to be chiral, axial chirality, the 2 ends must each bear 2 different substituents and the compound must not be superimposable on its mirror image. Left end H3C and C6H5, 2 different groups, yes. Right end C6H5 and CH3, 2 different groups, yes. However, the key point is whether the substituents on the 2 ends are the same or different. Left end has CH3, pH, and right end has pH, CH3, the same pair of substituents on both ends. When both ends of an alene bear the same pair of substituents, A, B, C is equal to C is equal to C, A, B, the molecule has a plane of symmetry and is optically inactive. It is like a mesotype alene. Specifically, this alene has CH3 and pH on both carbons of the alene termini, making it achiral due to an internal plane of symmetry. Therefore, compound C is optically inactive. D. The compound shown is mandelic acid, 2-hydroxy-2-phenylacetic acid with defined stereochemistry, H on wedge or on bold wedge. This has a chiral center and is optically active. Why? C is the answer. In alene, C, both terminal carbons bear identical sets of substituents, methyl and phenyl on each end. This creates a plane of symmetry in the molecule, making it achiral and optically inactive, unlike alenes where the 2 ends bear different substituent pairs. Therefore, the correct answer is C. Therefore, the correct answer is option C.